Hello, you are welcome to my class today. My name is Dr. Kingsley. In my class today, I will be taking you on alkynes. We have done alkane and alkynes in our previous videos. Please do well to check out those videos, subscribe, share and like those videos. Now, in our class today, we are talking about alkynes. Alkynes, they are what? They are unsaturated hydrocarbons with triple bond. Unsaturated hydrocarbons with triple bond. Now, their general molecular formula is CnH2n minus 2. Okay? If n, for example, is the number of carbon and the number of carbon becomes 1, we should be having C1H2 times 1 minus 2. Okay? That will give us what? CH. Okay, you can see that what? There is no what? Member that is CH. That is to say that methane does not exist. But if the carbon atom is equals to 2, we'll be having C2H2 times 2. Okay, then minus 2. That will be equals to C2H2. Okay, this is what? This is a ethyne. Ethyne is the first member of the alkyne series because ethyne exists. Then if our n is equals to 3, we'll be having C3H2 times 3 minus 2, and that would be C3 and H4. Okay, this is a propyne. So propyne is the what? The second member of the alkyne series. Now I can give you some of the few members of this alkyne series, okay, and their structures. Now, number of carbon. If we have number of carbon, then we'll have a name and their structural formula. So you see that the first member, as we said, is when carbon atom is equals to 2. So we have C, the name becomes what? Ethyne, as we saw, ethyne. And the molecular formula is C2H2. If n is equals to 3, we have a propyne as the second member, which is C3H4. Okay, if our carbon is 4, then we'll have the third member, which is what? Butyne. Butyne is C4H6. Okay, now if we have the next member, okay, which is number 5, we have a pentyne. Pentyne is the fourth member, and that is C5H8. Number 6, we have hexyne. Hexyne is C6H10. Then the next we have okay, number 7, heptyne. Heptyne is C7H12. Number 8, we have what? Octyne. Octyne is C8H14. Okay, C8H14. So this is the first 8 members. The first 8 members of the alkyne series. We can go on. Okay, let us go to number 9. Okay, the 9th member. Number 9. The 9th member. The 9th member of alkynes is nonine. Nonine formula. Remember the general molecular formula CnH2n, okay, minus 2. So when you put 9, it becomes C9H. 2 times 9 is 18 minus 2, and that is C9H what? H16. So here is a C9H16. Okay, number 10 is decyne. Decyne is C10H, okay, 18. Then we have the 11. We have on decyne. Undekined is the 11th, which is what? C11. Okay, H20. Then number 12 is a dodecyne. Dodecyne is the 12, which is a C12, H22. Then number 13, okay, is a tridecyne. Tridecyne is C13, H24. Number 14 is a tetradecyne. Tetradecyne is C14, H26. Okay. Now we have number 15, which is what? Pentadecyne. Pentadecyne is C15. Okay, H28. Okay, the next, number 16, I hope you can see from here, is a hexadecyne. Hexadecyne, okay, is a C16, H20, okay, H30. We are adding 1 carbon and 2 hydrogen as it goes, which means that each successive member differs by CH2 group. That is what we call the methylene group, each successive member. So this is what? Hexadecyne. Then if we go further, okay, we'll go to the 17th carbon of the alkyne series. The 17th carbon, number 17, is, okay, heptadecyne. Okay. Heptadecyne is C17, H32. Okay. Number 18 is what? Octadecyne. Octadecyne is C18, okay, H34. Then 19 is what? Nonadecyne. Nonadecyne is C19, H36. Number 20 is a icosine. That is C20, H38. Icosine. So you can practice what? The first 20 members of the alkyne series. Now, let us take the first one, which is what? Which is a ethyne, and see how the structure looks like. Now, remember the first one is C2H4, which is what? Written as C. There are 2 carbon atoms. We say that what? They have what? Triple carbon to carbon bond for the alkyne series. That is what we know them with. They have triple carbon to carbon, okay, bond. How many hydrogen do we have? Sorry, C2H2, okay. All right, so there are 2 hydrogen. We have hydrogen and what? And hydrogen. This is a ethyne. So from this ethyne, you can see that what? That there is what? 1 sigma bond. Ethynes, they have 1 sigma bond because triple bond is made up of 1 sigma bond and 2 pi bond. So if the first bond here is sigma, okay, that means these other 2 bonds, 2 of them here is what? Is pi bond. Okay, ethyne have 1 sigma bond and what? 2 pi bonds. So that when you look at it, you see because of the triple bond, okay, the bond angle is 180 degrees. If the bond angle is 180 degrees, it simply means that what? The alkynes, they are linear molecules. They are linear molecules because what? Their bond angle is 180 degrees. Now let us come to nomenclature of alkynes. How do we name alkynes? Nomenclature. Now, We can name alkynes using some rules. The first rule for the nomenclature of any organic compound is to identify the number of carbon atom. That is the parent chain. The longest carbon atom that bears the triple bond. The longest carbon atom that we must choose must be the one that bears the triple bond. Now, when we have CH3, C triple bond, C, CH3, okay, then you have what? You have let's say we have, okay, CH, all right, CH3, then CH3. So we need to identify the longest carbon atom that have the triple bond. If you look at this way, you see that we will not meet any triple bond. But when we go through the straight way, you see that what? That here, as we go from here to here, there is presence of what? Of triple bond. So this is the longest carbon atom that bears the what? The triple bond. That is the first thing that you must, identify. Rule number 1, identify the longest carbon, okay, that bears the what? The triple bond. If we have CH3, CH2, 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 okay, CH2, CH3. Then here you have 1, 2, 3, okay, that is CH, okay. When you look at this, you identify the what? The longest carbon atom that bears the what? The triple bond. Now from here to here does not have any what? Triple bond. Although when you look at it, is the longest carbon atom. But this longest carbon atom does not bear what? Triple bond. So we are not taking it as what? The longest carbon atom. Because any carbon atom unbroken that we choose must contain the triple bond. So when we count 1, 2, 3, 4, or we count 1, 2, 3, 4, 5, you will see that what? That this is what? The longest carbon atom that contains the what? The triple bond. This one is longer, but it doesn't have triple bond. This one has triple bond, but it's shorter. So that is why we are choosing this one. Then number 2 rule for the nomenclature of alkynes. The second rule is what? Number the longest unbroken carbon atom that bears the triple bond. Now that we have identified the what? The longest carbon atom, you need to number them, okay? Using Arabic numerals. That is 1, 2, 3. Use Arabic numerals to number it. But when you are numbering it, make sure that the triple bond takes the lowest position possible. It should take the lowest position possible. Now when you have CH3, CH2, 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 okay, C triple bond, then you have what? CH. So the longest carbon atom that bears the triple bond is this, okay? But how do we number? If we number from here, this will be 1, 2, 3, 4, 5. That means that what? The triple bond will be at number 5th what? Carbon. That is when we go to number through this way. But if you number through this way, your triple bond will be at the first carbon. The first carbon that bears the triple bond will be number 1. And here become 2, 3, 4, 5, and 6. So we are now saying that what? Since numbering like this, we give the first carbon that contains the what? The triple bond, the least position. So here is 1, here is 5. So the right numbering should now be what? This way. We are going through this way to give the triple bond the lowest number possible. So that is rule number what? Number 2. Number the what? The longest carbon that bears the what? Triple bond. Making sure that the triple bond takes the least position as possible. Then our number 3 is when we have what? A substituent. When we have a substituent, we need to what? Name the substituent first, okay, before naming the parent compound. So when we have CH3, C triple bond, C, CH2, CH3. Then let's say we have CH3 here. Now, what is the longest carbon that bears the word triple bond? This is the longest carbon that bears the triple bond. But we need to what? Number. When we are numbering it, we must number in such a way that the triple bond takes the what? The least position possible. So when we number here, this become 1, 2. It means that the first carbon that bears the triple bond is at number 2. But when we number from here, 1, 2, 3, the carbon that bears the triple bond from here will be at number what? Number 3. Which one do we choose? We choose the numbering that will give the first carbon bearing the what? The triple bond, the least position. That is why 1, 2 is better than what? 3 here. So this is 3, 4, and what? And 5. Now, having numbered, what do? You start naming your what? Your substituent. We did not number this carbon atom, and because we did not number it, it is a substituent. What substituent is this? This is what? Methyl substituent, because it have one carbon atom. So what will be the name of the compound? The name of the compound will be what? 4-methyl. 4-methyl. Then where is the carbon atom that bears the double bond? Where is the double bond? At number 2 position. So 4-methyl indicate the position of the what? Triple bond, I mean to say, not double. Okay? Yes. So indicate the position of the triple bond. That is number 2. Okay? Then you complete the what? The parent compound. Parent compound have 5 carbon atoms, and that is what? 4-methyl. Okay, we can 4-methyl, the major compound, which is what? Pent. When you name the substituents indicating the carbon atom where it is present, the next thing is for you to name the what? The arc. The arc. You need to name the what? The parent what? Carbon, which is what? Pent. Then before you indicate the position of the triple bond, which is number 2, then the name ends with what? Ine. So this is 4-methyl because of the position of the what? Of the methyl group. Then pent because it's 5 carbon atom. Then 2 is indication of the what? Of the triple bond. Then the name, instead of ending in "ame", we replace this "ane" with what? With "ine". So it becomes 4-methyl pent what? Pent 2 ine. So that is the name of that compound. Then we can take another one. If we have CH3, CH2, CH2, okay, C, triple bond, C, then we have a CH2, then we have CH2, CH2, and CH3. Maybe, okay, maybe we have somewhere here, okay, Br, and you are asked to name this compound. The first thing is for you to identify the longest carbon atom. That is what? That is present. But the longest carbon atom that we are choosing must be the one that contains triple bond. This side, the number is 1, 2, 3, 4, 5, 6, 7. There are 7 carbons this side. But along this side, there is no triple bond between any carbon to carbon. This carbon to carbon, no triple bond. 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 And carbon to carbon, no triple bond. So we are not going to accept what? That long carbon, because it doesn't bear triple bond. Then when we go through this way, okay, this will be what? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 carbons. When we come through this way, okay, this will be 1, 2, 3, 4, 5, 6. Also what? 6 carbons. Now, because we have 6 carbon here, we are going to what? Number these carbons. Okay, either this way or this way. But I think we have to number what? This way. Because there is what? A substituent here, which is what? A bromo group, which is bromine. Although, when we number here 1, 2, 3, 4, 5, and what? 6. Because we cannot accept numbering this way. It will give the triple bond a long number. But when we number through this way, the triple bond is already at number what? Number 2. Now, when you watch carefully, you find out that numbering this way, we did not number this carbon atom. And because we didn't number this carbon atom, this 1, 2, 3 carbon atoms, they are already what? A substituent. And because they are substituent, how many carbon atoms are they? They are 3 carbon atoms. 3 carbon atom substituent of the alkyl is what? Propyl. So this is a propyl. So I decided to number this way. Okay? So that what? I will capture bromine, B, which comes before what? Propyl, which is what? P. Because there are 2 substituents, we need to what? We need to name them alphabetically. 2 substituents should be named alphabetically. We name B, bromo, before what? P, which is what? Bromo. That is why we favored this what? This numbering. Now, if we are to name, the bromine is at number 4. So this is what? 4 bromo. The propyl is at number 3. So this is 3 propyl. Okay? 3 propyl. Okay? Then we have what? We have the longest carbon, which is 6. 1, 2, 3, 4, 5, 6. 6 is what? Is hex. Hex. That hex, where is the double bond? At number 2. Then you end with your ine, because the naming of the alkynes always end in what? In ine. So 4 bromo, the bromine is at number 4. 3 methyl, because methyl is propyl. Propyl is at number, okay, number 3. Then hex, because there are 6 carbon atom as the longest. Then 2 ine, because the triple bond is at number 2. Okay, that is what? The nomenclature. Okay, now number 4. Remember I told you, anytime you want to what? You want to name, and there are more than 2 substituents, we must name what? Alphabetically. That is what we did now. Now, if the alkyne are what? Asymmetrical alkynes. Let me say we have CH3, CH2, C, triple bond, C, then you have CH2, and you have CH3. This is what? A symmetrical alkyne. A symmetrical alkyne is an alkyne in which the triple bond have equal number of carbon atoms from either side. Now, we say that if we must number in such a way that the word triple bond will have the least number. But coming from here, it is 3. Coming from here, it is also what? 3. So, where do we number from? We can number from anywhere. Okay? But assuming there is a substituent, let's say substituent here, which is what? Something like BR here. We know that what? 3 is the what? The triple bond from here, and 3 is the triple bond from here. Okay? They are equidistant, the triple bond. So where do we now choose to number? We will accept to number from here, although the triple bond is at the same position, but this side bears substituents. Okay, that is why it is accepted to number from this side, which gives the substituent the least number, because the triple bond is already equal. So this will be 1, 2, 3, 4, 5, and 6. So the name is what? 2 bromo. The bromine is at number 2. 2 bromo. How many carbons? 6. Hex. Okay? Hex. Where is the position of the triple bond? Number 3. 3. The name will always end with what? With ine. So 3 ine. Now also, if we have CH3, okay, CH, then you have CH3. Then you have a C, triple bond, C, CH, you have BR, then CH what? 3. Remember, this is also a symmetrical alkyne, because the triple bond is at number 3 position here. The triple bond is at number 3 position coming from the other side. But now, if you now look at substituents, You see that they are the same, they are substituent here, they are substituent here. Okay, the position of the substituent, if we number from here, is number 2. The position of the substituent, if we number from here, is also number 2. So what are we having here? We are having the same position for what? For triple bond. Number 2, the same position for what? For substituent. So what do? We number from the side that the substituent is of lower alphabet. So we name bromo B before what? Methyl M. So this will be number from here 3, 4, 5, and what? 6. So this is what? 2 bromo. Okay, we have 5 methyl, then hex, because it's 6 carbon atom. The position of the triple bond is 3, then our name end in what? In ine. So that will become the name of that what? Compound. Now there are some cases where we have what? More than 2 what? Or 2 or more, okay, triple bond. What of if we have 2 or more triple bond? How do we name? Now let me show you that. That will give us, I think, rule number 5 or 6. Okay, let's say we have CH3, C triple bond, C, CH2, C triple bond, C, CH2, okay, CH3. They are what? A triple bond here, a triple bond here. Where do we number from? If we number from here, the triple bond, the first triple bond will become 1, 2, 3. But if we number from here, it will be 1, 2. So it will be better to number from here, which is 2, 3, 4, 5, 6, 7, and 8. When there are more than 1 triple bond, 2 or more, the name is named as alkyne. Then we put the word position. Okay, position of what? Of triple bond. We put the position of triple bond. So we are naming it alkyne plus position of what? Triple bond. Then plus what? Plus di, ine, tri, ine, etc. Okay, depending on the number of what? Of triple bond. We name alkyne plus position of what? Triple bonds. Position of triple bonds. Okay, then plus either is diene, or triene, or tetraene, depending on the number of what? Of a triple bond. Here we have what? 2 triple bonds, so it is a diene. So what is our alkyne? Our alkyne is the carbon. There are 8 what? Carbon. Okay, which is what? Because it's 8 carbon, it is octa. That is our alkyne. Octa. Okay, the position of the triple bond, one is a number 2, the other one is a number what? 6. We end with what? Diene. So this is octa 2, 6 diene. So that is how to name our what? Our alkynes. Please, I know that you have followed the class, you have gotten something. What you help me to do is to subscribe to my video, like my video, and share my videos to your groups that may need it. Thank you very much.